This video is on the objective determine the p-value for a hypothesis test for the difference between two means. And this is with population standard deviations known. Alright, because they're known, right, the test statistic will be a z-score, right? We'll be dealing with the normal distribution instead of the student's t distribution. And determining the p-value of your z-score in this kind of a test is no different than determining the p-value of your test statistic in previous hypothesis tests we've done, tests for one mean or one proportion. You'll see that when I go through this problem. Okay, so again, I say this in almost every video. If you want to see more about the topic, click on more instruction, look at their videos, their examples, their notes, and hopefully those help. Okay. So the question here is this. Andy Thompson is a dean at a local college. He's trying to determine whether the population mean GPA of undergraduate students at his college who have at least one job during the semester is different than the population mean GPA of undergraduate students at his college who do not have a job during the semester. Andy conducts research on the topic and assumes that the population standard deviation is 0.59 for undergraduates who have at least one job during the semester and 0.68 for undergraduates who don't have a job during the semester. So these are like sigma 1 and sigma 2, right, the known population standard deviations. The results of the survey are displayed in the table below. So we're going to let mu1 be the population mean GPA of students who have at least one job during the semester, and mu2 be the population mean GPA of students who do not have a job during the semester. Now look, they're giving us the test statistic, right, the z-score for the difference between these independent sample means. So they're giving us the test statistic. The z-score for our test statistic is 0.71. The question is, what is the p-value? What would be the p-value for that test statistic, for this hypothesis test? And they're saying, do not round your answer, compute your answer using the table from below. All right, so we need to formulate, in order to figure out the p-value, right, we need to know what kind of a test it is first. Is it a right-tailed test, a left-tailed test, or a two-tailed test, right? Remember how the p-value was calculated in a different way depending on what kind of a test it was. All right, so I'm going to go to some paper here and we'll write this out. So remember, the beginning of every test is, with some sort of claim that's being tested, or some sort of belief or statement that's being tested by the researcher or whoever's running the experiment or whoever's collecting the data. The claim being tested, reading back through this, what this person is trying to determine, he was trying to determine whether the mean GPA for the students that had at least one job, which was mu1, is different than the mean GPA of the students that don't have a job. Now, is different than is just simply is not equal to. So the claim being tested here is that the average GPA for the students with jobs is not equal to, is different from the average GPA of students without a job. Another way to say this would be that mu1, the difference, mu1 minus mu2, is not 0, meaning there is some sort of a difference between the average GPA of students with jobs and the average GPA of students without jobs. All right, then once the claim is established, right, you can form your hypotheses, the null hypothesis, the alternative hypothesis. This does not involve equals, right? So yeah, mu1, that's going to be represented then by the alternative hypothesis. Then the null hypothesis is the opposite of this, right? That mu1 is equal to mu2, or mu1 minus mu2 equals 0. And then what we'd be doing here is, we'd be assuming that this is true, right? You assume the null hypothesis is true, that the average GPAs for these students with jobs and these students without jobs, you assume that they're equal. And then, go through the process of finding your test statistic, the p-value. You compare the p-value to alpha, right, the significance level, and then you're going to decide, do you like this assumption or not? Are you going to reject it or not? And then based on that rejection or not, you're going to say something about the claim. Does the evidence support the claim or not? But we're not asked for all that yet, right? I'm sure there are other objectives where you're asked to complete all the steps. Right? So we'll see all those steps in those videos. But what happened here is they gave us the test statistic and asked for the p-value. Now, like I said, the p-value depends on what kind of a test. How you find the p-value matters. Depends on what kind of a test you're running. And that's, you can tell what kind of a test you're running based on how the alternative hypothesis looks. This is the parameter is not equal, different from some value. So this is an example of a two-tailed test. All right. So they gave us a test statistic. They told us the test statistic for our sample mean, the difference in our sample means was 0.71. Alright, now what I'm going to do is draw, this is z-score, so I'm going to draw the standard normal curve, right, the z distribution. So yeah, number line with z-scores, the distribution was symmetrical, bell-shaped. Underneath the peak was a z-score of 0. And then where did our test statistic fall? At 0.71, right? So over here. There's our test statistic. Alright. Now, being a two-tailed test, the p-value is, since this is to the right of the mean, it's near the, it's going to have a right tail area that I'm calculating. I'm going to calculate the area to the right of this value, this 0.71. What's the area to the right? And then double it. Or you could find the area to the right of 0.71 and add on to that the area to the left of negative 0.71. All right. But either way, the p-value in a two-tailed test is going to be, this area, okay, this area to the right of my test statistic here, again, because it's right of center, times 2. Or the area to the right of positive 0.71 plus the area to the left of negative 0.71. But again, all because it's a two-tailed test. If it was just a right-tailed test, I would simply find the area to the right of my test statistic. If it were a left-tailed test, I would simply find the area to the left of my test statistic. But a two-tailed test is, just a little more complicated. All right. Now what they're asking us to do is not use a you could use a calculator, but they're asking us to use the table provided to figure this out. So look at the table here. Now this is a z-score table. And remember, all the values in a z-score table give you area to the left of a particular z-score. So my z-score is 0.7, so I'm down in this row, right, with a 0.71. So the last row, and then I'm looking at this column with the 0.01, the 1 in the hundredths place. So my z-score was 0.71, and I'm seeing this number, 0.761, 76.1%. This is the area to the left of 0.71. All right, so back on my picture. Okay. They're giving me this area here, all the way to the left, forever. The area to the left of the z-score of 0.71 is 0.761. So that means this area to the right that I want, remember, is 1 minus that. So this area, right, the area to the right of 0.71 is 1 minus 0.761, or 0.239. And then the p-value, again, because it's a two-tailed test, is twice this, right? Both these areas would be 0.239. So if I double that, that'd be 0.478. 0.478. The p-value is almost 48%. It's 47.8%. Again, doubling that area. So back here, the p-value is 0.478. You see, they show you the exact same stuff I was going over on the table, talking about subtracting 0.76 from 1, getting the area to the right of 0.71, but then doubling that because it's a two-tailed test. Right, and that's a pretty big p-value, right? Almost 50%. I mean, that's pretty huge. And if you recall from most of our tests, the significance level, the value of alpha, is like 5% or 1%. This p-value would most likely be greater than alpha. And if you recall, when the p-value is greater than alpha, you don't reject. You fail to reject the null hypothesis. So in this case, I would again, I don't know what alpha is. We weren't given an alpha, but I would say we're probably not going to reject the null hypothesis here. Right. But all we're asked to do, though, is find that p-value, right? It's just determining the p-value for a hypothesis test of a difference between two means. Okay, so hopefully watching me draw some stuff, looking at a piece of paper, going through the table, hopefully seeing me do that, or maybe looking at the more instruction, or reading the answer explanations when they come up. Hopefully all this stuff helps you when you're working on this on your own. And thank you very much for watching.